In this video, we're going to talk about how to perform operations with complex conjugates. So the complex conjugate of a plus bi is a minus bi. To find the complex conjugate, what you do is you switch the sign of the imaginary term. So for example, the conjugate of 5 minus 3i is 5 plus 3i. The conjugate of negative 4 plus I is negative 4 minus I. Notice that the real part, the negative 4, stays the same, but we switch the sign in front of the imaginary term. So let's identify the complex conjugate of these numbers. So in A, we have 3 plus 5i. So when we find the conjugate, we're going to keep the real part the same, and we're going to switch the sign that's in front of the imaginary term. So 3 minus 5i will be the complex conjugate. Now let's try B. So we have negative 2 minus 7i. So once again, we're going to keep the real part the same, and then we're going to switch the sign in front of the imaginary term. So we have negative 2 plus 7i. So now you can go ahead and pause the video and try doing this example on your own. So in A, we have 2 minus 9i. So we're going to switch the sign in front of the 9i. And so we're going to get 2 plus 9i as the complex conjugate. In B, we have negative 3 plus 10i. So we keep the negative 3 the same and then switch this plus to a minus sign. So we can also multiply complex conjugates. Remember how we use the difference of squares to multiply certain types of binomials? So if we had the form a plus b times a minus b, that gave us a squared minus b squared. And we use that as a sort of multiplication shortcut whenever we had the sum and the difference being multiplied together. Remember, we have to have the same two terms in each of these binomials. So if we have x plus 3 times x minus 3, we can call x a, and we can call 3b. So that means we'll have x squared minus 3 squared, which is x squared minus 9. So notice that complex conjugates also have this same quality, right? So we basically have a plus b times a minus b. So we can use the difference of squares to multiply. So for example, if we're doing 5 plus 3i times 5 minus 3i, we can use the difference of squares to turn this into 5 squared minus 3i squared. 5 squared is 25. 3i squared, remember we distribute that exponent to both terms, so we have 9 and then I squared. So 9i squared, well, but that's just basically 9 times negative 1, right? So this is 25 minus 9 times negative 1. So that's like 25 minus negative 9. Well, minus negative will become a plus, so that's how we get this 25 plus 9, and that equals 34. So as always, we can always use our calculator to help us out when we're multiplying complex numbers. So we can do 5 plus 3i times 5 minus 3i. And when we hit enter, that gives us 34. So let's practice by multiplying 7 plus 2i times 7 minus 2i. So, since these are complex conjugates, I know that this is a plus b and then we have a minus b. So I can turn that into a squared. So in this case, 7 squared minus 2i squared. So 7 squared is 49. And then we have minus 2 squared I squared, right? Because both of those terms get squared. So we have 49 minus 4 times I squared, which is negative 1. So we have 49 minus negative 4. Minus negative becomes plus, so we have 49 plus 4, which is 53. So now you can go ahead and pause the video and try doing this example on your own. So we're multiplying two conjugates, so we can call 2a and 4ib. So that's going to give us 2 squared minus 4i squared. So 2 squared is 4. 4i squared gives us 4 squared I squared. 4 squared is 16, and then I squared will be negative 1. So we have 4 minus 16 times negative 1, which is basically 4 minus negative 16. Minus negative turns into a plus, so our final answer is 20. So remember, the conjugate of a complex number is a plus bi times a minus bi. When multiplying a complex number by its conjugate, you can use the difference of squares, a plus b times a minus b equal to a squared minus b squared.